Thank you. Okay. Because you students have the same voice. And confused. So members, when you are told to draw a cathode ray oscilloscope, this is what you draw. Now this is a cathode ray tube. This is a cathode ray tube. So a cathode ray tube has got a cathode, has got the anode, has got a fluorescent screen here, and it has also the filaments. So let us see, they are saying the cathode is heated by a low PD applied across the filament. So this is the filament, and the filament hits the cathode. So you note down those things. The use of the filament is to hit the what?
Cathode.
The filament, this one hits the cathode. The cathode, that is it. And what's the use of the cathode? The use of the cathode is to
emit electrons.
When what?
Electrons.
When
heated.
When heated, correct. So, or you can say emits electrons by thermionic emission or thermionically. So the emitted electrons are then accelerated by a high PD. Now, what's the use of the high PD? High PD, this word PD means, this PD means potential difference, potential difference. If you cannot remember potential difference, then you can say high voltage, voltage. What's the use of the high voltage? The use of the high voltage is to
Accelerate
the electrons from the cathode to the what? To the
anode.
To the anode.
Anode.
Good. So we are saying that the emitted electrons are accelerated by high PD between the filament and the anode, so that they move at a very high speed to constitute the cathode rays, so that they move at a high speed, full stop. You don't want to get things which will do what? Which will make you confused. Okay, now after there, so that is the cathode ray tube. That is what we call the cathode ray tube, and that's how you explain the cathode ray tube. Members, if you are trying to explain the cathode ray tube, you explain the cathode ray tube in terms of the functions of these parts which are here. That the cathode is heated by a low PD. Applied across the filament. The cathode then emits electrons by thermionic emission. So you can see you are explaining in terms of the functions of those parts. Then the high PD or the high voltage between the filament and the anode accelerates the electrons from the cathode to the anode. That's when you are explaining how a cathode ray tube works. Now, before we look at a cathode ray oscilloscope, are we together? Before we look at this cathode ray oscilloscope,
yes.
Let me see. I want to first. Before we look at this cathode ray oscilloscope, this one which is here, before we look at it, let us look at what are the properties of cathode rays. Okay, here they are telling you other methods by which cathode rays are produced. One, they are produced by photoelectric effect. Do you remember that? Members, do you remember that? They are saying ways how electrons, in brackets, cathode, because you are looking at cathode rays, which are electrons, ways how cathode rays are produced. Number one, they are produced by photoelectric what? Photoelectric
Emission.
Photoelectric emission. We have already looked at that. And two, they are produced by thermionic what? Thermionic emission. And also, they are also produced by natural radioactive you can say radioactive elements in form of what is happening? Oh. And it's calling me. I'm in the lesson. I don't want to finish. In form of beta particles. We shall see this later on. You are not seeing. We are not beta particles or beta. They are called beta particles. Beta. So we shall see later on what beta particles are. But beta particles, you should know that they are negatively charged. They are actually like electrons, and they are negatively charged. Or they are electrons. They are electrons. Okay, so three ways: by photoelectric effects, by thermionic emission, and by natural radioactive elements. We shall see radioactive elements. I can give you one example. Is uranium that is used in atomic bombs, or used to produce atomic bonds. So this uranium produces beta particles and also other particles. We shall see later on. So that's how electrons or cathode rays are produced in those three ways. Now, what are the properties? What are the properties of cathode rays? So cathode rays, they travel in a straight line. Members, are we together? Cathode rays travel in a straight line. Where are the members? Is it data?
So I said 5-minute break.
Are you sure? Are you sure?
Yes.
That was how can I call it? I just
Mistake.
no, it was a slip of the tongue, and I said yes, and I said 5 minutes. I meant only 1 minute.
Yes.
So I'm seeing they are coming back. I don't know what they are. Where's you are from? Yeah, from having breakfast. Okay. So number one, what are the properties of cathode rays? Cathode rays. One, they travel in straight line. Travel in straight line. Travel in straight line. Two, they are a negative charge. They carry a negative charge. So I can say negatively charged and negatively charged. Remember, here I'm just making a summary altogether. Negatively what?
Yes.
They are negatively charged. 2, 3, they are deflected by electric fields. They are deflected by what? Electric fields. So deflected.
What's the meaning of deflected?
By electric fields. Is that Esther?
Yes.
The word deflected, it means that change direction. Are we together?
Yes.
Changing direction. The way you may throw a ball from you towards the wall, and then once it reaches the wall, it hits the wall and then changes the direction towards you. So that is deflection. So it is deflected back to you. Is it okay?
Yes.
So also these cathode rays are deflected by electric fields. So we shall see how they are deflected by electric fields. 4, they are deflected by magnetic what? Deflected by Magnetic. Do you know magnetic fields? Yes? Hey, now you are in silence mode. Eh? Do you know magnetic fields, or do you know magnets?
Yes.
So magnets, what happens if you bring one magnet towards the other? What happens? There are two things that happen. One,
They attract
each other. Or they will do what?
or repel.
Yeah, they repel each other. So whenever they repel, it means that there are forces in between them that is making them not to attract one another. So those forces are due to the magnetic fields.
Magnetic field.
Hey, they are due to the magnetic fields, because those magnetic forces are always present in presence of magnetic fields, magnetic fields. So those magnetic fields are the ones that give rise to the magnetic force. Do you understand now?
Yes.
Good. So, and electric fields, do you know electric fields? Okay. But do you know electricity?
Yes.
If you know electricity, so they are also what we call electric fields. These ones, you cannot see them. They're also they're like magnetic fields. They cannot be seen. But whenever a wire has current passing through it, if you have a wire that has current passing through it, there will be electric fields that are around that wire. So there will be electric fields in that kind of moving that nature, like that. Electric fields around. So there will be electric fields around that piece of wire, moving, circulating around that piece of wire, So if you have one terminal this side which is positive and another terminal which is this side which is negative, there will be electric fields between those two terminals, moving from the positive to the negative, like that. And those electric fields, you cannot see them with your naked eyes. Even if you use a microscope, you may not see them because they are just fields. So if you put an electron here, this electron will be deflected by these electric fields. We don't know where the electron will go. Maybe it will go to the positive, because it's a positive, that's where the positive terminal is. And we know the electron is negative. It is always attracted towards the positive. Are we together? So if you have an electron here, if there is an electron moving, so this electron will go to the positive, to that direction, not to the negative, because the negatives always do what? Always repel. And the ones which have an opposite charge will do what? Will attract. So the electron is deflected. Instead of moving straight, it will go towards the positive. So that's what we call the deflection. Okay, then 1, 2, 3, 4, 5, then 6, they ionize air and gas molecules. Ionize air and gas molecules. Ionize air and gas. Ionize air and gas molecules. So members, we shall look at, you see these words which are here, Fleming's left hand rule, what and what. By the time you finish senior 4, you should be able to know all these things. And it will be just nice for you. The number 7, they cause fluorescence. Members, have you understood ionizing air particles?
No.
No, you have not understood. Because now, if we have air particles, if these are air particles, and they are electrons, and you have air particle, and there's an electron. So once this electron joins the air particle, it means that now this air particle is negatively what? Negatively charged. Yeah, that's what we call ionizing. So those air particles now start having a negative charge. If there are also gas molecules, and you introduce electrons inside there, those gas molecules will start having a charge. That charge is what we call that charge will be, that charge of the gas molecules will be negative. So we say that the gas molecules have been ionized. So ionizing means giving the charge to the air, or to the gas molecules. How? Those electrons, they can give a charge to the air particles. So they ionize. They cause fluorescence, not fluorescence. They cause what?
Fluorescence.
They cause fluorescence.
Fluorescence.
They cause fluorescence. They cause fluorescence to some substances, e.g. zinc sulfide. E.g. zinc
Sulfide.
I mean, I feel like Googling this thing and seeing how they cause fluorescence in zinc sulfide. Shall see. We don't have time. But do we have time? Let me see. I'm just in moods of checking this thing, how it causes fluorescence. He knows but doesn't know where he's supposed to connect from, I think. Let us wait. Let us fluorescence. Fluorescence of zinc. Zinc what?
Sulfide.
Sulfide. Let us see. Are you serious? No, this one is using fire. No, this one is using fire. I think when I get the right video of how there's fluorescence. But let me just show you this thing here. Now, there are some objects that glow. Members, there are some objects that do what? That glow. These objects that glow, they glow because they have zinc sulfide in them. I'm afraid to get to that video. They glow because they have zinc sulfide in them. So fluorescence, it means that something will glow, will give off light. You have seen rosaries, eh? Yeah? Those rosaries, yes. Once you hold the rosary in sunlight and then you hold it in a dark place, you see the rosary glowing, giving off light. So it means that it is glowing. So we call that fluorescence. So we shall see how the cathode ray tube also works, that when these electrons strike this bulb here that has zinc sulfide, coated with zinc sulfide, this screen is coated with zinc sulfide. So when electrons come and strike, let me use this one. This is the screen, the fluorescence screen. So when electrons come and strike this screen, the screen glows, gives off light. So this glowing is what we call fluorescence. So those electrons are negatively charged. Once they reach towards the screen gives off light, and that's what we call fluorescence, causing fluorescence. Very fast, because I want to show you the video of a cathode ray oscilloscope. Number 8, they darken the photographic plate. They darken the what? They darken the photographic plate or film. Now, for us these days, we are using memory cards, but in those days when we used to have those cameras that use negatives, members, do you remember those cameras that use negatives? So the photographic plate also appears like that. So it means that the electrons, they change the color of the photographic plate by darkening it. And then you can study what took place. We shall see how this photographic plate is used, for example, in a cloud chamber, those things that are ahead, we shall see them. They possess kinetic energy. They possess what? They possess kinetic energy. Why? Because we say that these electrons move. They are fast moving, they are streams of fast moving electrons. So if there are streams of fast moving electrons, so it means that these electrons must be possessing kinetic energy and momentum. Momentum, because they have mass. Electrons have mass, but their mass is very small, very small. They have mass, but the mass is very small. But anything that has mass has got momentum due to the kinetic energy. Because remember what Teacher Watumon told you, that momentum equals to mv, isn't it?
Yes.
So you look at the mass and you look at the velocity. So since they have velocity, it means that they are moving, they are in motion. And since they're in motion, so it means that they possess kinetic what? Kinetic energy. Lastly, they produce X-rays when stopped by matter. So if you have cathode rays and you stop them using a metal, and you stop them using a metal, you place a metal in their path. This metal instead is going to produce X-rays.
How do X-rays look like?
X-rays, how they look like?
Yes.
They are unlookable. You cannot see them. They have no shape, they have no color, they have no one. So you can't see them, but these are rays. X-rays are dangerous rays that are used to study in case you have a fracture, in case a lady wants to know the sex of a baby, you can use also X-rays to study that. They are used at police checkpoints to get to know maybe someone is carrying a firearm. You get it? All right. Now, this is an experiment to show that cathode rays travel in a straight what? In a straight line.
Straight line.
So what we do is that in the other tube, inside we put what we call Maltese cross. Maltese what? We put what we call Maltese cross. So the usefulness of Maltese cross is that once these cathode rays are produced from the cathode and they are accelerated towards the anode, once they reach the Maltese cross, they cannot go beyond the Maltese cross. Instead, we shall form a shadow.
A shadow.
Now remember, in light, we said that a shadow is one of the things that show that light travels in a straight what?
Straight line.
In a straight line. So even here we are going to use a shadow to show that electrons also travel in a straight what? In a straight line. How? By having this cathode. My lesson has to continue. Hello, members, do you get me?